This is a full GCSE Paper 2 from the Summer 2022 series. It was used for the Year 10 PPEs in April 2023. Okay, simple algebraic manipulation. We've got x to the power of 15 because it's the product of 5 and 3 here. Okay, expand each bracket out. We get 4x plus 12 plus 28 minus 14x. We notice that we have a total of 40 in numbers, and we've got 4x minus 14x, which is minus 10x. Okay, and this one we've got to factorize fully, this expression here. Well, the highest common factor is 3 and x squared. Okay, that goes outside a bracket, and we have then 5x and plus y, and that's it. Okay, you can multiply that out to check that it goes back to that. A question here about a transformation. In particular, this is a translation. You must have that word for 1 mark. So translation is the type of transformation. Okay, and then you need to give some information about the translation, and that is how far it moves left and how far up. And we normally do that in a column vector. It goes left 5 places and it goes up 6 places. Okay, so it's a translation of -5, 6 in a column vector like that. This question is about writing an error interval, and this is basically saying what range of numbers could 90 have come from if it was given to the nearest meter. Well, the smallest it could have been is 89.5. Okay, and if it was 89.5 or more, then it would be rounded up to 90. Okay, the maximum it could be is up to, but not including, 90.5. But you'll notice the inequality sign's already been correctly done for you, because that's up to, but not including 90.5. And that's the answer. Okay, this is a question about the number of square meters allocated per person in a field at 2 different festivals. Okay, one is a bit more crowded than the other. We've got to find out how much more space per person is allowed at Festival B than Festival A. That suggests that Festival B has the higher number. So what I'm going to do is work out the area of the field at Festival B first, okay, which is 700 times 2000. That's the dimensions of the field, and then divide that by the number of people there, which is 6750. Okay, and I don't need to know what that number actually is, but I do know it's the bigger of the two from this part of the question. So I'm going to just subtract the other one from it. The area is already given as 80,000, so we don't actually need to work it out. But we do need to divide it by the number of people at Festival A, which was 425. Okay, if you do that subtraction, okay, and put that on the calculator, you get about 19.1 something. Okay, so the answer is 19 meters squared. Okay, and that's all you need to do to answer that question. So it's actually quite easy. There's a lot of information to take in first. This is about the effects of length and area, okay, and the units of them. So 300 centimeters squared is the same as 3 meters squared. Well, that's not true. Okay, and we've got to say why. Well, the best way of saying why is to show what he should have done. So 300 centimeters squared is the same as 3 meters squared. No, because 3 meters squared is 3 meters squared is 3 times 100 centimeters times 100, which is equal to 30,000. Okay, 30,000 centimeters squared, not 300. Okay, and that's it. Here we have a question about 3 points in a straight line. We're given coordinates of 2 of them. We've got to find the coordinates of the third. We also know something about the ratio of the distances between the various points. So what I'm going to do is draw a sketch to illustrate roughly what's going on. So this is just a sketch. It's not drawn to scale, but it will give us an idea. So we've got a vertical y-axis down there. Okay, we've got a horizontal x-axis here. Okay, we're going to plot the points roughly in the right place. So we've got this point L here, which is the point with coordinates -3, 1. Okay, and then we've got this point M, which is at about 4, 9. So I'm estimating on my scale it's about there. Okay, that's my point M. And then we've got this third point 1.5 times that distance away up here somewhere. If I draw a line through those points, I'll be able to extend it. Okay, so that's going through LM and it's going up to about there somewhere. Okay, so the end of that red line is roughly where N would be. Okay, now I'm just going to show some information to help me work out the coordinates of N. So that's to the bottom or below M, and that's from M down to that point there. Okay, so I can put those 2 measurements on from the coordinates given, and then I'm going to go 1.5 times that distance across. Okay, so whatever that was, I times it by 1.5, and whatever this was, I'm going up by 1.5, but they're similar triangles, so that would happen anyway. So that point there is where the point N would be on my sketch. Okay, so the question is, this distance here was from -3 to 4 was 7, and this was 8. So timesing by 1.5, or 3/2, this must be 10.5. Okay, and 8 times 3/2 is 12. Okay, so I've just got to a bit of addition now. Well, look, I'm going from this point here. We know what this point is here, M. So that's 4, 9. Okay, so 4 plus 10.5 is 14.5. Okay, and I've got here this point here, 9 plus 12 is 21. So that's the coordinate of the point N. So I'll just write it here so you can see 14.5, 21. Okay, and you could show the coordinates of these here as well if you wanted on the diagram, but it's written there anyway. So I think that's enough working to show that you understand the problem. Okay. Okay, this is a very simple question about repeated proportional change. Basically, if it's falling in value by 4% per year, then each year it's worth 96% of what it was the year before. So all we need to do is take 679, okay, and multiply it by 0.96 to the power of 3. Okay, and that's it. And we just put that in the calculator. It will give us 600.735 Okay, but we only need to give that to the nearest penny because it's money, so it's £600 and 74p, and that's it. You don't want to be doing it year by year as separate calculations, and you don't want to be subtracting 4% and then working out the new value. It's much quicker just to apply a repeated change of 96% 3 times over. Okay, this question is one of those comparison questions where you've got to compare, in this case, the cost per litre or the cost per gallon of fuel in 2 different countries and then state which is cheapest. Well, look, let's start with Spain. There's lots of different ways you could make this comparison, okay? One way is just to look at the cost in euros per litre, which is what I'm going to do because that's how the question starts with Spain. So for Spain, okay, let's see what the cost is per litre. Well, that's easy to see because it's simply going to be 27 divided by 18, which is exactly 1.5. Okay, so that's easy. We'll leave that. Now we'll go to Wales and see what happens there. So in Wales, okay, first of all, we pay £40.80, but that needs to be converted into euros, okay, to make a like-for-like comparison. So to do that, I'm going to have to divide it by 0.85. Okay, so £40.80 divided by 0.85, that would give me the cost in euros of the same, of 8 gallons of fuel in Wales. But I'm going to need to divide that answer by something. So I don't need to work out what that is. I just need to put it in a bracket and then use it in a division to divide by the number of litres of fuel that bought. Well, look, we know it's 8 gallons and it's 4.5 times 8 litres. Okay, so we just need 4.5 times 8 there. Put that into the calculator as it is, and that gives us 1 1/3. Okay, 1.33 recurring. Okay, so we can immediately see that Spain is more expensive, so Sam is wrong. So we need to finish by stating clearly that Sam is wrong. If you don't do the comparison at the end, you won't get all the marks. So Sam is wrong. Okay, and the reason he's wrong is stating the obvious, really, that 1.33 is less than 1.5 and therefore cheaper in Wales. Okay, and that will answer the question and get you all the marks. There's lots of other comparisons you could have made. You could have looked at the price of 1 gallon in Spain in pounds if you wanted to and did it that way, but it's got to be an accurate and properly calculated comparison. There it is. Okay, this is a calculator question. All you've really got to do is put it carefully into the calculator, but you'll be amazed how many people get these wrong. You just got to be really careful. So this means the cubed root of this, okay? If you don't know how to do the cube root, you can do that top line to the power of 1/3, which is the same thing, if you prefer. This is 7.2 to the power of a half, which is the same as the square root of 7.2. So it doesn't really matter as long as you understand the method you're using. Now, if you put it into the calculator and press equals as it is, you don't need to write it down again because it's already there. You get 0.7, okay, and I'll always give more digits than needed, 73937, at least 6 digits, because then it shows that you've definitely worked it out properly. Okay, and then you've got to give it to 3 significant figures. So you can now look at that and see that it does in fact round to 0.739. Okay, I would discourage you from working out each part separately because you're likely to produce rounding errors if you're not careful. So just do that and put it in as it is, but very carefully. Okay. Okay, in this question we are dealing with pressure, force and area, and really it's about substituting into a formula and rearranging. So we're told what the force is and we're told what the pressure is. So I'm just going to literally put the numbers I know into the formula and rearrange it. So we'll start with 187.5, which is the given pressure. Okay, 187.5, and that's equal to the force, which is given as 180, divided by the area. Now the area is given as a length of 1.2 and a width of x. So because it's a rectangle, we just need to do the product of those two things. So underneath there for area, I'm going to put 1.2x. Okay, now if I rearrange this to find x, that's what I need to find. I just have to multiply both sides by 1.2x and divide by 187.5. So I'll do that first. So 1.2x must be 180 over 187.5. Okay, and then one more step would just be to divide both sides by 1.2. So the final step would be 180 over, well, I'm just going to put 1.2 times 187.5 underneath. Okay, and that's it. Now I can enter it on the calculator exactly like that using the fraction line, which I can get off the calculator. Okay, that will work. If I'm going to use the division instead, I need to put this bottom line in a bracket. Okay, but when you put that in the calculator, it comes up with 4/5, okay, which is exactly 0.8. Okay, and that's the answer. 0.8 meters, because it's the length of the side of a rectangle. Okay. This question is about box plots and distributions, and what we've got to do first is Andrew's claiming that 3/4 of the data lies between these two numbers. He's wrong, and we've got to explain why. Well, these two numbers, as it says in the question, are the lower quartile and the upper quartile. Okay, and between those two lie the middle 50% of the data. All right, now what he's saying is that 3/4 of the data is there. So what we should do is something like this. I've already typed it earlier to save a bit of time. So these numbers are the LQ and UQ. This represents half of the data, not 3/4. Okay, that would get you the mark. Now on to this question. We've got to complete a box plot with the information given here in order, very conveniently, but always check that. So the lowest value is 30, and that's the end of one of the whiskers. So don't plot them in the wrong place. They need to be accurate. Okay, lower quartile is at 80. Okay, make the box about 3 squares wide, so it's about there to there. Okay, and then we've got the median at 170, which is there. Okay, and then you've got the upper quartile at 260, which is here, and finally the end point, which is at 350, the highest value. Okay, make your whiskers like that, and then the box joins up the lower quartile and the upper quartile. like that. Okay, so there's your box plot, and you've got to compare the distributions of the sales. Now, when you do this, you must compare the medians and you must compare the interquartile ranges. Don't talk about the mean or anything else, use those two. Okay, ideally include the numbers, but if you do, then you must have them accurate. So I've said the median for the online store is 200, which is greater than the median for the shop, which is 170. And similarly, the IQR for the online store is 190, and the IQR for the shop is 180. That's it. And that will get you the marks. Okay, we have here a classic proportion problem where we use what we call a unitary method. So Kieran has 13 workers he can use for a job. 6 workers take 14.5 days. So I'm just going to do a little table here. So this is workers here, okay, and this is days here. Okay, so 6 workers take 14.5 days. So therefore, if he only had 1 worker, that's 1/6 of the workforce, it would take 6 times as long, which is 14.5 times 6, which is 87 days. Okay, but he hasn't got 1, he's got 13. So we only need to do now for 13 workers, we just take 87 and divide it by 13. Okay, 87 over 13, put that on the calculator, and that gives us 6.692. Okay, 6.69, etc. Now, that's less than 7, therefore he has enough workers because there are 7 days that he's allowed. So it's less than 7, so therefore enough workers. Therefore enough workers, and that's it. Okay. In this question, we have to show that the 2 lines are parallel. If they're parallel, it means the gradients are the same. So the general equation for a straight line is often written as y equals mx plus c, okay, where m is the gradient. Now in the first one, okay, we can see that for this one, m equals 2, because it's got the 2 in front of the x. It's already set up in this form, all right? But for the second line, we've got to rearrange it. So I'm going to take this line and I'm going to write it as 5y equals, I'm adding 10x to both sides and subtracting 4, okay? And then I'm going to divide by 5 to get y equals 10 over 5 is 2, and 4 over 5 is 4/5. So that's the equation of L2, and that has a gradient of 2 as well, because m equals 2. Okay, so all I need to say now is a little conclusion. The same gradient, again, you don't need to write very much at all, just put same gradient, that's the key thing, same gradient. And then, just to be on the safe side, at this point I would say what the gradient is, even though you've worked it out. Same gradient equals 2, therefore, okay, parallel. And that shows that you fully understand the question. Okay. Okay, to carry out this enlargement of scale factor -2 with centre 0, 0, best thing is to do a couple of what we call ray lines. Usually use a pencil for this, but I'm going to use a red colour there. Now I'm just going to take that corner project a line through the center of enlargement and continue it the other side. Now you just have to be careful. It's going along 3 and up 2, along 3 up 2, along 3 up 2, and you just got to kind of line it up and make sure it's in the right place. Okay, and then I'm just going to do one more point only, which is this one here, because if you do too many it can go wrong. You can overcomplicate things. So I'm going along 2 and up 4 to get to O. So I go along 2 up 4, and I can see it's going to go through the point 24 and 48. There it is. Okay, that's as far as I need to go, because I know that this face here is going to be replaced with this one here. I'll do it in a different color. So this is going to be joining. So I've got there and there. So that point would need to go through to there. Okay. So I've got 2 points correctly joined together, and now I know that the rest of it will follow from there, because I can go along here, that's 2, and I can therefore go the other way from here, which is 4, because it's twice the size. Okay, this one would go to here, okay, and this one would come across from here to here. Okay, now you might be able to see that quite easily, okay, but you need to get those points in the right places. If you weren't sure about that last point, you might want to extend the ray line. I'll just do that a little bit further so you can see what it might have looked like. It would have carried on through there, and in fact on this side it also should carry on through there as well, which indeed it does. Okay, so that gives you now 3 points. Okay, so that's an enlargement scale factor -2 with the center 0, 0. This question is about the recapture method for estimating the number of fish in a lake. Now when we do a question like this, we assume that fish are caught and tagged, and then they completely randomly mix together before any recapture is carried out. Now look, in this case 180 fish were tagged, okay, and on the following day 305 fish were caught from the lake, and only 45 of those were tagged. So what we can see is that the proportion there were 45 tagged from the second catch out of the 180 that were tagged. Okay, so that means that 1/4 of them were recaught. Well, if 305 were recaught, that represents 1/4 of the fish in the lake. So 305 times 4 would be the number of fish originally in the lake, which is 1,220. That's it. Okay, this is a question about hourly pay and the ratio between 2 different people and their hourly pay, and how it changes when they each receive the same increase. So what's happening is they start with these amounts of money. So we'll just say that we don't know how much they're actually paid, but we know they're in the ratio 6:5. So we'll say that Marta was paid 6x and Khalid was paid 5x. Okay, now each of those has £1.50 added onto their hourly pay. So Marta now gets 6x plus 1.5, and Khalid gets 5x plus 1.5. Okay, now we know that they're in the ratio 13:11. So what we can actually do is we can say that this divided by this, in fact if I just move this, that would make it quicker. So that divided by that, okay, would equal 13/11. Okay, and then we can do some cross multiplying. Okay, so we put the 11 up there with that and this up here with the 13. So we end up with 11 times 6x plus 1.5. So 66x plus, now 11 times 1.5 is, 10 is 15, it's 16.5. Okay, and that is equal to 5 13s are 65, so it's 65x plus, and that's going to be 19.5. Okay, just multiplying 1.5 by 13. And so we solve that equation. Well, if we take 65x from both sides, we have x plus 16.5 equals 19.5. Okay, and therefore x must be exactly 3. Okay, so x is £3. And because x is £3, we've got to now say what their original pay was. Well, 6x is 6 times 3, which is 18, and 5x is 5 times 3, which is 15. Okay, and that's it. Okay, a Venn diagram question. Now this is really easy if you're careful. Okay, and just follow the information. It's 6 marks. Okay, look, there's 100 customers altogether, and they use type A, B, or C social media platforms. All right, 4 use all 3 types, so you put 4 in the middle there. Okay, and 16 do not use any of them. So that goes outside in the box, but outside of the 3 circles. Okay, so we've accounted for the first 2 lines. Now, 8 use both type A and B, but not C. So this is A and B here and not C. Okay, because if it was C as well, it would include that bit. Okay, and now we have 14 use both type B and type C. So B and C together, where they overlap, in there is 14. But we've already got 4 in there, in the middle, so there's only another 10 left, which go in there. Okay, now we're nearly done. We've got 62 in total use type A. At the moment, there's 2 gaps in A, which the total of all that should be 62, but we don't yet know how to split that bit there, so we'll look at the next clue. All 20 who use type C also use at least one of the other 2 types. So there's 20 who use type C, and they also use A and B, or A or B. So this has to make 20, meaning that must be 0, and this must be 6. Because basically there's no one who uses just type C on its own, you see. Now we can go over here and fill in the rest of A, because we know the total of these is 62. So if you take away 8, 6 and 4, that's 18 from 62, that gives you 44. Okay, so the total in ring A is now 62. Okay, and we know as well that there's a total of 100 customers. If we add up all the numbers that we've got so far, that only comes to 84. So that means, no, 88. So there must be another 12 to go, which belong in there. Okay, and that makes a total now of 100. Okay, so that's quite a quick process if you just follow it logically. One of the customers is chosen at random. Given that the customer uses type A, find the probability that this customer also uses type B. Well, this is really easy. This is conditional probability. You're told for sure that they use type A. So it's a fraction out of 62, okay, because there's 62 in type A. And of those, the number who also use B is those there, 8 and 4, which is 12. So the probability is 12 out of 62. You don't need to simplify it because it hasn't asked you to. So that's the answer. And that's the question done. Okay, this is quite a tricky problem, but we just need to take it carefully, step by step, and write everything down. So we've got to find this length y here. Okay, we know that the total volume of this shape is 120 pi. Okay, and I'm just put a couple of arrows in because these two lengths are going to be useful. Now that is 7/2 because it's half the diameter. Okay, which means that this one here is y minus 7/2. Okay, so that's the height of the cone part, which is y minus 7/2. Now we're going to now just use these formulae to write an expression for the volume of the whole shape. So it's half of a sphere, so it's 2/3 of pi times the radius cubed, 7/2 cubed. Okay, and then we've got to add on to that the volume of the cone, which is 1/3 of pi times the radius squared, okay, times the height of the cone, which we've just said is y minus 3.5 or y minus 7/2. And we know that the total volume equals 120 pi. Okay, so there's nothing difficult about that. It's just making sure we write it all down in the correct way. Now, we're going to simplify this. We notice a factor of pi in every term, so we can just cancel that out, literally just strike it out, because everything divides by pi on both sides of the equation, you see. And we can also multiply everything by 3, and that will clear the fractions, okay? Makes it a little bit easier to follow. So let's go back to doing that. So we can ignore the 3's and the pi's. So we've got 2 pi, okay, not the pi, that's gone, 2 times 7/2 cubed is 343, okay, over 8. And then we've got the third's gone and the pi's gone, so we're just left with 7/2 squared, which is 49/4, okay, and that's multiplied by y minus 7/2, and finally we've got 120 pi. The pi's gone, and because we've multiplied these by 3, we must multiply this by 3 to get 360. Okay, so it's starting to look simpler already. Now the 2 and the 8 cancel here to give me a 4, so that's got a 4 under it, if you like. So if I put that as that goes, and that becomes a 4, if I now multiply everything by 4, I will clear the fractions over here completely. So I think we'll do that next, and we get this expression. So we have 343, okay, 343 plus 49 lots of y minus 7/2, and that equals 1440. Okay, we just got to rearrange that now to find y. We'll do that over here. So basically we can take away the 343, divide by 49. So let's do that. So y equals, okay, so I've got 1440. I'm doing quite a lot in one go here, so be careful with this. 1440. I'm going to take away the 343. Okay, I'm going to divide the whole thing by 49. Okay, and there's one more thing I need to do, which is to subtract the, or rather add the 7/2 to that, because it was y minus 7/2, you see. Okay, now you can put that on the calculator, and that will come out with 25.88. 25.887, and then it keeps going, but you want it to 3 significant figures, so 25.9, and it's the height, so it's in centimeters. Okay, and that's it. And then for this part B, explain the effect this would have on your answer to part A, and that is if you expanded the diameter of this, in other words, stretch the shape out sideways, what would happen to the height? Well, it would obviously get smaller, so y would decrease, and that's all you need to say to get that last mark. Okay, and that's the job done. Okay, this is a problem about the sine rule and cosine rule in non-right-angled triangles. We've got to calculate the length of QS, which is this side edge here. Okay, now in order to do that, we may need to work something else out on the way, and I suggest that the best approach is to find this length here, which I'm going to call X first, and then use that to find Y with another calculation. So to find X, we can use the cosine rule because we have a length opposite a known angle, and we know the two sides adjacent to that angle. So we know from the cosine rule that x squared is equal to 11 squared plus 9.4 squared, okay, minus 2 times the product of the numbers we've just written down, times the cosine of the angle between them, which is 27 degrees. Okay, and then we could immediately conclude that x itself would be the square root of that. So we just take off the squared from there, okay, and put a square root symbol on the right hand side like this. Okay, and we can use that instead of x in our calculation. Okay, so we now need an expression for y, and we know from the sine rule that y divided by the sine of 88, okay, so y over the sine of 88 is going to equal the same as x over the sine of 41. Okay, that's how the sine rule works. So if we rearrange that to get y equals, we just have to multiply both sides by sine 88. So I can say that y equals sine 88 times x. Okay, but I know that x is this thing here, so I could just go straight to that and make a copy of it and write that down. So I'm just going to take the copy of all of this, okay, and just bring it down here. So sine of 88 times all of that, okay, and then divide it by sine of 41, okay, so the sine of 41 goes underneath there, and that's the calculation I actually need to put into the calculator. So at no time am I actually needing to know what x is. Now obviously you need to be very careful to enter that correctly into the calculator. I'll just put that y down a little bit, don't really need to, but just to show that it's in the middle of the fraction like that. Okay, so put that into the calculator, make sure the calculator's in degrees, and it gives you the length of y, and it comes to on the calculator 7.6318, okay, 6318, and so on. Just show it to a few decimal places and then give your answer as requested to 3 significant figures, which of course is 7.6318. 6.3. Now the diagram won't be drawn necessarily to scale, but you should be able to look at the diagram and think, well, is that a reasonable answer? I mean, in other words, if we got an answer that was way above, in the 70s or 80s, we would say, well, that can't be right, looking at that diagram. But this seems reasonable in the context of that diagram. Okay, that's the question done. Okay, a simple question about functions here, really. The first part is just to find g of 16. We're given the definition of g of x there. So g of 16 is just going to equal the cubed root of that thing above, but with 16 instead of x. So it's the cube root of 2 times 16 minus 5, which is the cube root of 32 minus 5, which is the cube root of 27, okay, which is just 3. Okay, so that was easy enough. Now for the second part, we've got to find the combined function h applied to the inverse of g. So to do that, we first of all need to find the inverse of g. So what is the function g to the minus 1 of x? That's what we're going to find out. Okay, so we're going to start by setting y equals to cubed root of 2x minus 5. And we're going to rearrange it to make x the subject of the formula. Okay, so the first step is to cube both sides. So y cubed must be 2x minus 5. Now we need to add 5 to both sides, so y cubed plus 5 equals 2x. Okay, so from that we can conclude that x equals y cubed plus 5, okay, divided by 2. Okay, so all of that divided by 2. Okay, now we write it in terms of x, so we define from this the function g to the minus 1 of x to be x cubed plus 5 over 2. Okay, so we give our final answer in terms of x, like that. Okay, so that's the inverse function g to the minus 1 of x. Now we have to apply h to that. Now h is the reciprocal. Okay, so h of g to the minus 1 of x. Okay, h applied to g to the minus 1 of x is simply means 1 over g to the minus 1 of x. Okay, now g to the minus 1 of x is this thing here. So 1 over that is the reciprocal of that, which is equal to 2 over x cubed plus 5. So it's just inverting it. 2 over x cubed plus 5. And that's actually the answer to the question. Okay, so all I need to do, in fact, is just put that on the answer line. There. Okay, that's the answer. Okay, here's a problem concerning circle theorems and calculating an unknown angle, showing reasons for every stage of your working. Okay, so this is the angle we've got to find, the angle CDE. But we need to find other angles on the way, and we need to give reasons, which I've pre-written here to save a bit of time. But 132 is in the center. This angle here at A is therefore half of that, which is 66 degrees. Write it on the diagram by all means, but you still need to show how you got it. So I need to say that angle BAD equals 66 degrees, and the reason is that, as I just said, the angles at the centre, the angle at the centre is twice the angle at the circumference, right? Next one, I need to find angle BCD, this one in here. Okay, and that's going to be 180 take away 66, which is 114. Okay, and I need to put the reason for that as well. So let me write that down. Angle BCD equals 114 degrees, and the reason for that is because they're angles in a cyclic quadrilateral. Opposite angles in a cyclic quadrilateral add to 180 degrees. Okay, third one is going to give me this one here. Okay, this angle in here is going to be 114 taken from 180, which will go back to 66 degrees, which we've already had. And this often happens in these sorts of problems, but you need to give reasons at each stage. So that was angle DCE. Okay, angle DCE. That is equal to 66, and the reason for that is because angles on a straight line add to 180. Okay. Now, that's the third point, and the final point to get all the marks would be to find the unknown angle here, which is going to be 180 minus 66 minus 16, because they're in a triangle, you see. So the angle we want, angle CDE, okay, is going to be 180 minus 66 minus 16, okay, which comes to 98 degrees, and that is because the angles in a triangle add to 180 degrees. Okay, now there's a lot to do there, and it would be very tempting just to quickly work out the angles and write them in, but actually to get all the marks you need to give the reasons for each stage of the working. So without those reasons you don't get those marks. Okay, and don't take too much notice about what it looks like. That may be reasonably accurately drawn, but you need to do the calculations. Okay, this is a question about transforming graphs of functions. Now, this is the function f of x, and we've got to sketch the graph of f of minus x. And this basically means all the x coordinates of the original become the negative of what they were. So this point here will move to here. Okay, this point at 0 will stay where it is. This point at 1, negative 2 will go to negative 1, negative 2, which is there. Okay, this point here at negative 1, negative 1, 1 would be at 1, 1 here. This low point here would go to here, and finally the graph would finish, leaving the grid at about that point there. So we just need to do a smooth line as best we can that joins those points together. Let's see if we can do that with this tablet. It's a bit more tricky than it is with pen and paper, but it will go up there, it will peak about there, come down to about here, and then it will disappear off up towards that point there. Okay, now over here we have to transform this graph with a translation, and they're telling me that the point Q would end up at 90, negative 5. So you need to just remind what the tan graph looks like. That would be 360 there. Okay, this point here would be at 180. Okay, and this is 0. This is 90 here. Okay, so the point Q moves across to 90 from 360, and it goes down 5. Remember, this goes down infinitely on the tan graph, so we'll just put a mark about here where we think 5 might be. Okay, so basically the graph moves left 270 and down 5. So g of x is going to be defined as, instead of the tan of x, it's going to be the tan of x plus 270, because that moves it left 270, and then we need to subtract 5, and that will be the answer that they'll be looking for. Okay, and you could write that down there on the number line, but on the answer line, but it doesn't really matter, that's fine. Okay, job done. Okay, for this question we've got to find the set of values of x that satisfy both of those inequalities. And the word "and" is really important here because you'll see why later, but we need to make sure it satisfies them both. So this is how it works. We find the critical values for each one. Okay, so the critical values, let's do the first one. That's the difference of two squares. X minus 7, x plus 7 equals 0 to find the critical values. Okay, so the critical values are x equals 7 and x equals minus 7. Okay, we imagine that we have a quadratic plotted on an x-axis. We'll just put the x-axis, and we know the quadratic curve will do something like this. Okay, but we know in this case that those values are negative 7 and 7. Okay, now in order to be greater than 0, that means above the x-axis, I'm interested in this part here, where x is therefore greater than 7, or this part here where x is less than negative 7. Okay, so that's how we solve that one. Now we'll look at the other one, okay, which is this one here. Now this factorizes, okay, you could try using the quadratic formula, but if I just factorize it, and always try and do that first if you can. Okay, again, we're finding the critical values, so I'll just say here that these are the critical values, CB. Okay, we're doing the same here. Okay, so 5x, and that factorizes to plus 9, 5x plus 9 and x minus 8. If you do a FOIL on that, you'll multiply it out and get back to this, so it does work. And so this gives us that x equals negative 9 over 5, or negative 1.8. And the other value is that x equals 8. Okay, now again, we want it to be greater than 0. So if we do our little sketch, in this case, we have our quadratic curve, and it has two values where it crosses the axis, the critical values, and this time we have them at negative 1.8 or negative 9/5, and the other one is at 8. Okay, so if we just highlight the areas we want it to be greater than 0, so it's above the axis. There. Now, we need to find the values of x that satisfy both of them. So this is telling me that x has to be less than minus 7, and this is telling me it has to be less than minus 1.8. Well, in order to satisfy both of them, it has to be less than minus 7. So I'm just going to make a note of that over here. X is less than minus 7. And the other side, this tells me x has got to be greater than 7, but this tells me x has got to be greater than 8. So to satisfy both of them, x has to be greater than 8. Okay, so what I'm going to do is just make a note of that too. X is greater than 8. Now, because it uses the word set of values, a set of values is shown like this. So we have x in a set bracket, which is a curly bracket like that, such that x is less than 7, minus 7 rather. That's the first set. And that is intersected with the other possibility, which is that x is such that x is greater than 8. Okay, so that's a full proper set notation answer. Now you might get away with just using the two inequalities, but if you could learn that, that's an intersection symbol. That's proper set notation, which you would be using if you were doing A-level. Okay, so that's the answer to the question, and that's the end of it.